you're back in the chicken lab. Only this time, and I want you to imagine now that this is the bone. Okay, this is the bone. Only this time you didn't use one strain gauge, you used 4. That means you put 2 strain gauges on one side of the chicken's bones, and you put 2 strain gauges on the other side of the chicken bone. Sounds good? Okay. And I want you to, and we're going to go through this sort of conceptually. Now, first of all, that's a lot more work, right? Instead of having to glue, I don't know how you do, right? Instead of having to glue 1 strain gauge to a little chicken leg, now you got to glue 4? Why'd you do it? What are you thinking? And then you put all that into a Wheatstone bridge, right? Now, when the chicken moves, we already know what happens, right? When the chicken moves, R2 gets bigger, R3 gets bigger, R1 gets smaller, and R4 gets smaller, and the bridge where there, changes, right? That's what we went through, right? The first part of this class, right? All right. Now let's think about temperature. We're all the way back here. I'm sorry, but it's not 0. You couldn't do it. They don't sell them. And the temperature in the room starts to go up. And the chicken starts to get hot. Its bones start to get hot. Right? Let's say it goes up by 10 degrees. Right? Oh, and then I got a problem because this strain gauge just went up by 10 degrees. Its resistance changed. This strain gauge just went up by 10 degrees. Its resistance changed. This strain gauge just went up by 10 degrees. Its resistance changed. And this strain gauge just went up by 10 degrees and its resistance changed. So let's say these, I want you to think it through. Let's say this is 1 ohm, 1 ohm, 1 ohm, and 1 ohm. 1 ohm, 1 ohm, 1 ohm, and 1 ohm. And now the room got warm. So now it's 2 ohms, 2 ohms, 2 ohms, and 2 ohms. 2 ohms, and 2 ohms, and 2 ohms, and 2 ohms. Oh, but wait a second. That's not going to change anything. If this is 1, 1, 1, and 1, right, then these voltages are the same. I don't know what they are, but they're half of this voltage, right? Like if this is 10 volts, and this is 1, 1, 1, and 1, then we have 5 and 5, 0. Okay, but now the room got hot, right? So we have 2, 2, 2, and 2. What's this voltage? It's still 5, because 2 and 2. And what's this voltage? It's still 5. So as the room gets hotter and all these start to change, the output doesn't change, right? You've made a very bad circuit if the goal was to measure temperature. If the goal was to measure temperature by getting 4 temperature sensors, which were identical, and putting them into the bridge this way, you have made a circuit that doesn't change with temperature. But your goal wasn't to measure temperature, was it? Your goal was to measure strain. You see how it all comes together now? The 4-arm Wheatstone bridge, right, is sensitive to strain, but it's really important that these 2 are on the bottom and these 2 are on the top. Right? They have to change differently, right? Because if they all change the same, plus, 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 it becomes insensitive, right? So in fact, the real reason we talked about strain gauges and Wheatstone bridges, right, other than to show you how the same ideas come back and back, is I wanted to give you the first example of a circuit that eliminates the noise. And you could say, but wait, it requires like a lot of things, right? I mean, you have to have this. Yes, there are a lot of steps that had to be into it, but this is a practical and extremely effective way to get rid of noise. Make a circuit, all right, that is not going to change with the noise and is going to change with the signal. And as we go through this class, we will see other examples of circuits that do that. Hint, right? One of them is going to be called a filter. which you've heard about before, right? But whereas in circuits, filters are like an assignment, in this class, a filter is something that lets the signals through, but not the noise. Right? That's how we're going to use filters, as tricks. Okay? So the real takeaway from today was, I want you to understand what signal is, I want you to understand what noise is, and I want you to understand that for the rest of this course, and even as you're working through your projects, that's what you should be thinking about.